Hello, everybody. Um, excuse me. I am going to go through this is the homework 2.1. You need to have submitted homework 2.1 before you watch this video. Because I'm going to go through each and every question. I'm going to have you input what you got as your answers. And then I'm going to go through the questions just to make sure we are pretty solid. So input your answer for question 1 now. So, for question 1, the first thing you should do is we can factor out an x out of all three of these. So when we do that, that'll take that x to the third to x squared. We'll get plus x and minus 6. And this is all set equal to 0. We will then put that x squared plus x minus 6 into the box. So we put x squared in the upper left, negative 6 in the bottom right. We want something that multiplies to those two multiplied together, so negative 6x squared, but adds to that middle term of a positive 1x. So the two numbers that multiply to negative 6 but add to 1 are going to be 3 and 2, where 3 is positive and 2 is going to be negative, right? Because negative 2 times 3 is going to be a negative 6, and negative 2 plus 3 is a positive 1. So then we say out of the first column, what can I take out of both of those? That's going to be an x. Out of the second column, I can take out a 3. Out of the first row, I can take out an x. And out of the second row, I can take out a negative 2. So I'm going to keep this x that I already took out front, and then I'll have x plus 3, x minus 2. And then I'll set each of these equal to 0. So I should get that x equals 0, x equals negative 3, and x equals a positive 2 as my solutions. You should be making these corrections with me as I go. So, on to number 2. Again, first thing we always want to check for is a GCF. So I can divide all of these by 2, and all of them have an x squared attached. So I'm going to take that out. When I do that, when I take it out of 2x to the 4th, I'm going to be left with just x squared. When I take it out of negative 12x squared, I'll be left with, when I take it out of negative 12x cubed, I'll be left with negative 6x, just x. And when I take it out of 18x squared, I'm going to be left with just a regular 9. And again, we're still equal to 0 here. So now I can take what's in the parentheses and put that in the box. So I have x squared and 9. So I want something that multiplies to 9x squared, but adds to the middle term of negative 6x. So the two numbers that multiply to 9 but add to negative 6 are going to be a negative 3x and a negative 3x. Excuse me. So out of the first column, I can take out an x. Out of the second column, I can take out a negative 3. Out of the first row, I can take out an x. And out of the second row, I can take out a negative 3. So we again have that 2x squared out front. And then we have x minus 3. And that would be squared is equal to 0. However, we only need to set these factors equal to 0 once. So when I set this 2x squared equal to 0, that's going to give me that x equals 0. And then I just need to set x minus 3 equal to 0. And that's going to give me that x equals 3. So I only have two answers there, and that would be 0 and 3. All right. Again, we should do GCF here. Both of these are divisible by 10, and both of them have an x squared. So I can take out both of those, and that'll leave me with x squared minus 9. Now this is factorable by a difference of squareds, right? So we take the square root of the first term, which is x, and we add the square root of the second term, and then we take the square root of the first, which is x, and subtract the square root of the second. And then we set each of these equal to 0 and solve. So from that first one, we get that x equals 0. And then from the next two, we also get positive and negative 3. Okay. So with number 4, we don't have a GCF here. But we do have 4 terms, so we're just going to go ahead and throw that whole thing into the box. So we always want to make sure highest degree is in the upper left, lowest degree is in the bottom right, and then I go in order, but that's kind of a personal preference. So out of the first column, we can take out an x. Out of the second column, I can take out a 5, yeah. First row, I can take out an x squared, and second row, I can take out a negative 6. So we have x plus 5 and x squared minus 6, and we do need to go further. Because even though 6 is not a perfect square, we can still treat it as a difference of squareds. It's just going to be the square root of the first, which is x, plus the square root of the second, which is the square root of 6. That does not simplify. And then the square root of the first minus the square root of the second. So it would be x plus the square root of 6, x minus the square root of 6. Again, all still equal to 0. So then we set each of these equal to 0. So our answers are going to be negative 5, and then plus or minus the square root of 6. Make sure you don't drop that square root. That square root is a part of the answer. All right. Again, we want to check GCF. We don't have a GCF here, so we again have 4 terms. So we'll go ahead and put that in the box. So in the upper left, we put 4x cubed. And in the bottom right, we put 54. And then we just fill in the rest. So out of the first column, I can just take out an x. Out of the second column, it may be a little hard to see, but I can take out a negative 6. Both of those are divisible by negative 6. Again, I'm doing negative because the closest box is negative. Out of the first row, both of those are divisible by 4x squared. And out of the second row, the closest box is negative, so I take out a negative 9. So then I have x minus 6 and 4x squared minus 9. So we actually have a pretty difference of squareds here, where we do the square root of 4x squared, which is 2x, plus the square root of 9, which is 3, and the square root of 4x squared, which is 2x, minus the square root of 9, which is 3. So we'd set each of these equal to 0, and we'd solve. So again, the first one is going to give us a positive 6, and then when you solve the next two, you'll get both positive and negative 3 halves, and just leave it as a fraction. Alrighty. So again, we always check for that GCF first, and that GCF is a 4x here. And when I take that out, I'm going to get x minus 4. So you may have wanted to jump to perfect squares because you saw that 4 and that 16 and knew that those were perfect squares. But checking that GCF first makes this way easier because now it's already factored. And I can say 4x equals 0 and x minus 4 equals 0. So my two answers are 0 and a positive 4. Alrighty. Next page. So then we're getting into these, and these aren't set equal to 0. So we need to do that first. We need to get them set equal to 0. So we subtract 81 from both sides. I can't take out a GCF, but I do have a difference of squareds here. So again, I'm taking these square roots. The square root of 4x squared is going to be 2x, plus the square root of 81, which is 9, and then the square root of 4x squared minus the square root of 81. So again, this is that difference of squareds. We'll set each of those equal to 0 because we got this set equal to 0, and we can solve those. So we get that x equals plus or minus 9 halves when we do solve those. Alrighty, so again, it's not set equal to 0, so we need to do that first. So we're going to add 15. If it's not set equal to 0, it's going to make your life really, really hard. So when we add 15, this will turn into a minus 3. And I'm adding it to that 18 because those are the like terms. So now I can go ahead and I can put this into the box. And I can say highest degree term in the upper left, 8x squared, lowest degree in the bottom right, and we'll multiply them together. So we want something that multiplies to a negative 24x squared, but adds to the middle term of negative 2x. So the two numbers that do that are going to be a negative 6x and a positive 4x. So out of the first column, I can take out a 4x. Out of the second column, I can take out a negative 3. The first row, I can take out a 2x, and the second row, I can only take out a 1. So we have 4x minus 3 times 2x plus 1. And again, we set each of those equal to 0 and solve. So from the first one, we should get 3/4, and from the second one, we should get negative 1/2 when we solve it. So again, it's not set equal to 0, so that's the first thing we got to do. Unfortunately, we don't have any like terms that I can combine that 40 with, so that just means it has to get tacked on to the end. And then we do the box. Highest degree in the upper left, lowest degree in the bottom right, and multiply them together. So we want something that multiplies to a negative 40x squared, but adds to the middle term of 3x. And this is going to be a positive 8x and a negative 5x. So out of the first column, I can take out an x. Out of the second column, I can take out an 8. First row is x. Second row is negative 5. We set each of these equal to 0, and we solve. So we're going to get that x is equal to negative 8, and x is equal to a positive 5. Okay. Again, this one's already set equal to 0, which is nice, but we always want to check for a GCF. So all of these are divisible by 3, so I'm going to go ahead and take that out. That's going to leave me with 2x squared plus 3x plus 1 equals 0. And then we go ahead and we do the box. So we put 2x squared here and 1 here. So we want something that multiplies to 2x squared but adds to 3x. So that's going to just be 2x and 1x. So out of the first column, I take out an x. Out of the second column, I take out a 1. First row, I take out a 2x. Second row, I take out a 1. So we have 3, and then x plus 1, 2x plus 1. Now, if I try to set this 3 equal to 0, that doesn't give me anything because there's no x involved. So I'm really only worried about setting these two other pieces equal to 0 and solving. And when I do that, I'm going to get that x is equal to negative 1 and a negative 1/2. Again, I have to get it set equal to 0. So I'm going to add 3 to both sides. I can't combine it with anything. So I just kind of tack it onto the end there. And then I use the box. So in the upper left, I have 4x squared. And in the bottom right, I have 3. I'll multiply those two together. So I want something that multiplies to 12x squared, but adds to a negative 8x. So that's going to be a negative 6x and a negative 2x. So out of the first column, I can take out a 2x. Second column, closest box is negative, so I'll take out a negative 3. First row, I can take out a 2x. And second row, I can take out a negative 1. So we get 2x minus 3 times 2x minus 1 is equal to 0. So we get that x is equal to 3/2, and x is equal to 1/2. Alrighty. So here we again should start by taking out a GCF. So we can take out a 3, and that'll leave us with x squared plus 2x, I'm sorry, minus 14. So then we would try to put this in the box, and we would get x squared and negative 14. So we'd have something that multiplies to negative 14x squared. But we want something that adds to 2x. Well, the only multiples of negative 14 and 2, the only multiples of negative 14 are 2 and 7, and neither of those are going to give us something that adds to 2. Or 14 and 1, and that doesn't work either. So this is actually not factorable. We will talk later about how to solve these. So this is not factorable. There's nothing more we can do here. We've taken out our GCF, and that's about it. We'll talk next class about how to solve the ones that aren't factorable. Now this one is a little special. So again, we want to start by getting it set equal to 0. So we'll subtract 36. Now, we did this in class as a U. You don't have to do it as a U if you prefer not to. But you can say this may look a little intimidating. And I think the next one, yeah. So I'll show you it both ways. We can say that U is equal to x minus 5. Now when we do that, we can change this to U squared minus 36. So I'm replacing that x minus 5 with that U. And then we can factor this. We take the square root of the first term plus the square root of the second, and then the square root of the first minus the square root of the second. And then we substitute U back in. So that's going to give us x minus 5 plus 6 and x minus 5 minus 6. We will simplify those. It'll become x plus 1 and x minus 11. And when we solve each of those, our two answers are going to be negative 1 and a positive 11. Alrighty. So similarly here, we are going to subtract 39 from both sides. So that's going to give us 4x minus 3 squared minus 46 equals 0. Now, with this one, if you don't want to do the U, you can go ahead and take the square roots right here. We just want to make sure we are keeping 4x minus 3 together. And we do want to try to simplify 46 if we can. 46 is divisible by 2. That gives us 23. And that's actually not, it doesn't go any further. So this is just going to stay as the square root of 46. Okay, so again, 4x minus 3 plus the square root of 46. Again, that 4x minus 3 is not going anywhere. And then it'll be minus the square root of 46. This is still a difference of squareds. Now, one thing we should note is the only difference between these two is the plus and the minus here. So if we can solve one of them, then we just need to include plus or minus. So I'm going to set 4x minus 3 plus the square root of 46 equal to 0. I'm going to have to move that 3 and that 46 to the other side. So I'm going to get that 4x is equal to 3 plus the square root of 46. And then to solve for x, I divide by 4. So I'm going to get that x equals 3 plus the square root of 46 over 4. But again, I also want to include the minus option. So this one's a little tricky. It's 3 plus or minus the square root of 46 all over 4. Alrighty. Excuse me. So again, for this one, we do want to make sure that we have our numbers on the same side. So I am going to subtract 113 from both sides. So that's going to give me negative 108. And I want to keep my x squared positive if I can. So I know that I can take out a negative 6 from both of these. And I'm going to rewrite my order to kind of help me out there. So when I take out a negative 6 from both of these, that gives me a positive x squared plus 18. Now the problem with this is, again, I can't factor this further. This is not a difference of squareds, and so therefore it cannot factor further. There's nothing more I can do here, and that's okay. This actually gives imaginary solutions, and we'll talk about that eventually, but just not today. Alrighty. Now again, we're going to subtract 22x to get this set equal to 0. So I'm going to put that between the x squared and the 120. And then I can go ahead and put it in the box. So we have x squared and 120. We want something that multiplies to 120x squared, but adds to a negative 22x. So that's going to be negative 12x and negative 10x. So out of the first column, I can take out an x. Out of the second column, I can take out a negative 12. Out of the first row, I can take out an x. And out of the second row, I can take out a negative 10. So we should get that x equals 12 and x equals 10. Alrighty. Excuse me. I can't take out a GCF here. It's already set equal to 0. I'm going to go ahead and throw it into the box. So in the upper left, we have 2x squared. In the bottom right, we have 21. So we'll multiply those two together. We want something that multiplies to a 42 x squared, but adds to the middle of 17x, which is going to be 14x and 3x. So out of the first column, I can take out an x. Out of the second, I can take out 7. Out of the first row, I can take out a 2x. And out of the second row, I can take out a 3. So we have 2x plus 3 and x plus 7 equals 0. And then we'll set each of these equal to 0 and solve. So our two answers are negative 3/2 and negative 7. Okay. And last one, again, we have to get it set equal to 0. So we're going to add 7x to both sides. So when I do this, this turns into 14x, because I'm going to combine those like terms together. And we can go ahead and factor from here. So we'll put it in the box. In the upper left, we'll put 5x squared. And in the bottom right, we'll put negative 3. So we want something that multiplies to a negative 15x squared, but adds to the middle term of 14x. So that's going to be a positive 15x and a negative 1x. So out of the first column, I can take out an x. Second column, I can take out a 3. First row, I can take out a 5x. And second row, I can take out a 1. So I'm going to get x plus 3 times 5x minus 1 equals 0. And then we'll set each of these equal to 0 and solve. So x equals negative 3 and x equals a positive 1/5. And that will finish us going through that homework.